Welcome everyone to the SciManDan Podcast. We are on episode number 5. I can't believe we're on 5 already. This is the place where science and conspiracy collide. And I've got huge news. Katz is back. He is back from the brink in this co-hosting chair. How the devil are you feeling, buddy?
I'm feeling a lot better, thank you very much. A lot better.
Good to hear. Really good to hear.
Good.
You all good? All set for Christmas?
I am. I'm really looking forward to it. Obviously, it's going to be a very digital Christmas. We've got all the grandparents set up with webcams for Christmas Day and whatnot, so we can spend some virtual time. It's nice. Yeah, I'm looking forward to it. What about yourself?
Good. Yeah, I'm pretty much done. I've wife likes to make a thing how I'm only ever in charge of her gifts and she's in charge of the rest of the family's gifts. And I've tried to make a point this year of not that being the case. And I'm like, yep, I'll go and buy these for the kids. I'll go. So, I'm in the good books at the moment. But anyway, let's get our guest on. We've been talking about this for ages, haven't we, Katz? Today's guest is a theoretical physicist, author and broadcaster, a University of Surrey Distinguished Chair and Fellow of the Royal Society. The Sunday Times referred to him as an affable egghead. It is, of course, the brilliant Professor Jim-Al Khalili, OBE. Welcome and thank you for joining us today.
Thank you very much for having me, Dan. Looking forward to it.
Yes, absolutely. We've been looking forward to this for weeks. How are you doing? Are you set for Christmas?
Pretty much. I think we've decided now. My two kids are coming round. I call them kids. They're in their late 20s now, but they'll always be the kids with their other halves. So there's going to be 6 of us. That's it. Sorted. Nice. 3 households, 6 people. My dad lives nearby, but we'll have to pop round. And I think same as Katz, we're going to be probably having Zoom chats with him at some point over the day. But so he's fine.
You've got your bubble sorted.
Exactly.
Yeah, good stuff. Good stuff. So, Jim, I was looking through some of your publications, and I was interested in the one that you did called Sunfall. It was the dystopian thing set in the future.
It's my one and only novel.
Well, look, I've got a book idea, and I just want to quickly pitch it to you. And when I first read the blurb to your book, I thought, you've stolen my idea. But then it was to do with obviously the magnetic field failure and all that. So picture this, right? The Earth was hit by some sort of a meteor or asteroid, and it slowed the rotation of the Earth, and it started to slow the rotation of the Earth so much that after a certain amount of time, it became in synchronous rotation with the sun. So there was only ever one side of the face of the Earth facing the sun, and there's one side that's really cold, and the humans that are left are kind of living in the Terminator line, the dusk dawn line, right. And they've got to try and survive in that. What do you think? Is that the bones of a book? Is that a bones of a story?
Absolutely. Sounds like a great idea. I mean, that's the thing. I mean, I guess like you, writing the book, I was just thinking of all the Hollywood disaster movies I'd watched.
Yeah,
I'm not. What can I do that's going to become a Hollywood blockbuster, basically?
Good way of thinking. Yeah. Well, I don't consider myself a great writer, so. If I start seeing these sorts of books coming out, then we know why.
You'll know how it's been leaked.
As long as it's not you, Jim. As long as it's not you. Anyway, let's crack on. So, the first thing, obviously, where does the love of science come from? What was the inspiration for you to get involved in science?
Well, for me, I don't know if you know, but I grew up in Iraq. So my mum's English. My dad's from Iraq. He's now obviously settled in Britain. But as a kid, I grew up in Baghdad.
Okay.
And during the summer months in Iraq, it's so hot that you sleep on the roof. So, it's always really exciting as kids. Yeah, it's hot and it's warm enough to sleep on the roof. So I used to lay in my bed on the roof, looking up through the mosquito net, up at the stars. So I'm like 11, 12 years old. And the sort of questions which I guess a lot of kids will think about, does space go on forever? How far away are the stars? What are the stars made of? What makes them shine? And all those questions that sort of bubbling around. And I think at some point at school, I must have had a good, as is often the case, you have a good science teacher and they get you hooked. And I had a good physics teacher, and I realized that if I wanted answers to these big questions about, the meaning of reality, then I had to study physics. It was no good, there's no other subject that is going to satisfy my curiosity. And from then on, from my early teens, I still felt my career was going to be as a professional footballer with Leeds United. Right. Mm-hmm. So that hasn't quite panned out. But the physics thing, ever since then, ever since the age of about 13, I've been in love with it.
Yeah, the football thing doesn't pan out for any of us, does it?
I'm not alone.
No, Katz is Blackburn and I'm Southampton, which you're probably not too happy about from where you live, unless you don't have those sorts of ties.
Sorry,
to the football team where you live?
I've never lived in Yorkshire. Think of myself as an honorary Yorkshireman.
Oh, okay.
I supported Leeds, because in the early 70s they were the team to support.
Yeah,
so it was like the fear of the support, and I've just haven't been able to shake that off.
Fair enough. Absolutely fair enough. So you're a prolific science communicator. Kat says that you are one of his favourites. But you're a quantum physicist by trade. Richard Feynman once said nobody understands quantum mechanics, but how true is that today? Because obviously we've come a long way since then, haven't we?
Well, what Richard Feynman, and he was one of the greatest physicists of the 20th century. He was no fool. But what he meant when he said no one understands it, he didn't mean, here's a theory, we don't know how to use it. Because basically, the way we're talking now, we're recording this podcast over Zoom, we're using technology, we're using computers. None of that technology would be possible if we didn't understand the quantum world, the world of atoms and electrons and subatomic particles. So we do understand quantum mechanics in the sense that this is the most powerful, successful theory in all of science. What Richard Feynman meant was that it doesn't make sense. It works, it's accurate, it's correct. But when you think, again, how can that be the way it is? That's what gives us the headache. And we still have that same headache today that we had 100 years ago when the theory was first being developed.
Katz, you're a biologist, aren't you? Well, you're a biologist first, physicist later, aren't you?
Yeah. And I wish I'd have taken a different path and started with the physics first. When I landed into teaching after a biology master's degree, school needed a physics teacher, and I sort of retrained over the last 20 years and taught the physics. But what I really love about the subject, and something I'd like to say about yourself, is when I'm studying and trying to learn the things that I need to teach to the kids, I find it so difficult. I find it so, so complicated, but the ease at which you explain it. How difficult is that for you to take something that you must understand so well and boil it down to communicate it in the way that you do? Is it frustrating that you've got to boil it down so much? How difficult is that?
I've always enjoyed it. I guess part of it is that in maybe my social group of friends, ever since I was a student at university, weren't other scientists, weren't other physicists. So I was very used to being, down the pub or dinner parties or whatever, and explaining things sort of hand wavy way without any technical detail. So I find that fun, and I like judging the level of understanding of the person I'm talking to, so I can notice when that light bulb moment when you think, oh, I see what you mean. So finding the right terms, finding the right phrase, finding the right examples is something I enjoy. But I don't get frustrated. I think I'm so used to explaining and communicating. And very often, a lot of the metaphors and analogies that I use, they're tried and tested. I know what works and what doesn't. I know the best way of explaining something. I know what detail to leave out, because it's not, that's just going to confuse you if I go into that. So I won't even go there. Just give you the bare bones.
It's brilliant.
Yeah, it was funny enough. I was going to move on to that actually, because I recently saw an interview that you gave where you were talking about the public being scientifically literate and how it's very difficult to express the things that you want to express, especially in what the current circumstances are in now, without a scientifically literate public in general.
Yeah, when I started science communication, and I didn't do it altruistically because I think the public needs to know the stuff. I did it because I enjoyed explaining. But there's one side of it is the fascination, the curiosity. What happens if I fall into a black hole? Oh, what does Einstein's theory of relativity mean? Or the exciting, sexy stuff. The Large Hadron Collider discovering extrasolar planets and that business. But I think certainly what we've really, really realized this past year during the pandemic is that it's not enough just to talk about the fascinating science. People need to know how science works. Very early on very early on in the pandemic, people were getting so annoyed because scientists are saying, "Oh, we don't know. It could be this, it could be that. We don't know if we take these precautionary measures, or you wear a face mask, you don't wear a face mask, you do this, you do that. Should you just wash your hands?" It wasn't the scientists, can't make up their minds. It's that the way science works is that, you learn from evidence, gathering data, comparing ideas with each other. Yeah. So I think explaining to the public, when we say we want the public to be more scientifically literate, it doesn't mean that they all know how to solve equations, right? It doesn't mean they all become experts in astronomy or genetics. It means they understand that in science, it's okay to be uncertain. It's okay to make mistakes. What is the value of evidence? What evidence do you trust, and what evidence is just misinformation? That's what the scientific training gives you.
Yeah, and we're seeing it now, aren't we, with the vaccine and how quickly it's come through, and there's a lot of people doubting the speediness that we've got it out.
They assume it's because it's fast, therefore we must have cut corners, or that we haven't tested it. So getting across what clinical trials are. Yeah. 40,000 people have been taking this vaccine for months, and we see the results. And only when we see the results that it's safe and that it works do we then open it up to the rest of society. But those things aren't obvious to me. Why would people know all about clinical trials unless it's explained to them?
Well, they're not. But correct me if I'm wrong, Katz. Isn't clinical trials part of the GCSE curriculum for biology?
We mention the need for trials, and we mention an order of trialing on a small number of people, then expanding that group of people. But it's really no basic. More detailed than that in the specification. It's a couple of sentences and that's it.
Okay, fair enough. Jim, your newest book, I think I'm right in saying, The World According to Physics, where you introduce readers to the fundamental space, time, energy and matter, and then you move on to what you describe as the 3 pillars of modern physics: quantum theory, relativity and thermodynamics. How much of a leap is that for the average person to go from those 4 initial ideas to those 3 more complicated ones?
Well, yeah. I mean, it's a compact book. It's almost pocket size, and it's not something like 1,000 pages that you have to wade through and learn everything you need to know. What I wanted to do in this book is get to sort of the very limits of our current understanding very quickly, without the need for people to sort of have the whole baggage of training in physics to understand those concepts. Okay. So yeah, it is a jump. And I think, people who've got a background in physics will read it and go, yep. Oh, that's an interesting way of putting it. Oh yeah, I understand that. But it's not really aimed for them. It's aimed for people who may have heard of some of the concepts, are curious, want to know more, and I just want to give them the headlines. And so when I talk about quantum mechanics, I say what it is. I talk about relativity and the nature of space and time. And I talk about thermodynamics, heat, and the way you order stuff in the universe. So they are difficult concepts. I just try. Sometimes I think I put it in a really nice way that probably people feel, oh yeah, I get it. But then they probably go away, and a few weeks later, it's what was his point there? I've made a difficult concept simple. And that gives people the impression that it really is simple when it's not.
Yeah, that makes. I do actually do that. I read something that's quite complex, and within a week, I would have to go back and reread it to try and. That's
quite natural. We're like that anyway in science as well.
Yeah, absolutely. But the 4 fundamentals, though, the space, time, energy, and matter, they're things that most people could probably grasp quite quickly, aren't they?
They are. I mean, matter is stuff, energy is energy. But actually, when you dig into it, the way a physicist understands these concepts, they're not straightforward at all. When you say space, well, that's space. It's where stuff happens, right? It's the air that I breathe. It's the room that I'm sitting in. And then Einstein talks about space is actually space-time, and it's 4-dimensional, and it's the shape of a gravitational field. You think, oh, hang on a minute. I thought I understood it. I thought it was a normal word. What is time? Well, I can tell you what the time is, but what is the nature of time? Suddenly, what you think are simple concepts are actually hugely deep philosophical ideas.
Yeah, absolutely. Katz, do you, how much of you, because you taught A-level physics, didn't you?
Yes.
How much is there in that on thermodynamics and quantum theory and stuff like that?
Thermodynamics and quantum. We do have a full unit of thermodynamics, but more related to what I guess we're speaking about, though, we talk about time dilation. And I find that the kids get really, really, really fascinated about time dilation. And then they want to ask me questions that I can't answer. So I go online and I look at videos by Professor Jim-Al Khalili and try and figure out what the answer is. But that's, to me, the thing that always gets the wow factor A-level physics is when that comes up. And I I wish I had the understanding to be able to articulate it, better,
Yeah.
Well, I mean, I think kids these days know, I mean, partly because of the internet, because a lot of Hollywood movies, the science fiction digs into some of these topics. So they're remarkably sort of informed about ideas like, quantum physics or space-time and wormholes and whatever. That's exciting. And that's what they're curious about. But when you have to explain the science behind it, then that's a whole, that's way beyond just the science fiction explanation.
Yeah.
Well, that's when you end up in my classroom, you see. I know I said off air that you end up in class. When they ask me those questions like that, I think, I'm not quite sure, but let's see if we can find someone who explains it. And then that's where you come in.
There I am on YouTube.
Katz, you'll give me the impression, Katz, that most of your science lessons are just videos from YouTube.
But exactly. And I'm not getting any credit for this.
I'm sure they're much better than that, Katz. I'm sure they are. But that leads on nicely to if I'm watching a film or something like that, I tend to like the films that are more entrenched in real science, like things like Interstellar, which has obviously got a good grounding in terms of what actually could be going on up there. However, have you seen Ant-Man?
Yes.
So Ant-Man, he uses the quantum realm, and then later on he uses it to travel through time. Without confusing me too much, how conceivable is that theory?
Well, so the traveling through time business is what Ant-Man does in Avengers.
Exactly, yeah. In Avengers.
Endgame.
Yep.
Now, I happen to... So the science consultant on Avengers Endgame is a mate of mine.
Oh, okay.
He's an American physicist called Sean Carroll.
Right.
He works at Caltech, California Institute of Technology. And he gave them the ideas for, how can you travel through the quantum realm and travel back in time? It's based on very speculative science. Right. It's not silly. It's not wrong, but it's not particularly feasible in reality.
Okay.
So it's the idea that yes, you can possibly travel back in time. This is Einstein's idea of wormholes, and you might get wormholes down at the quantum scale, down in the tiniest length scales. But how Ant-Man shrinks himself and makes himself big, that's just nonsense.
Yeah.
That bit. But the traveling back in time is fine. It's miniaturizing himself that I don't like.
But it's interesting because he was stuck in there, wasn't he, for what he thought was 5 hours, and it was 5 years. So time gets weird, really weird in the quantum realm as well.
Yeah, I mean, and that's exactly the same as you mentioned Interstellar. Yes, when Matthew McConaughey travels and he's on this planet that orbits this supermassive black hole, and just a few hours for him are equivalent to decades going by on Earth. That is all correct.
Yes.
Were we to find a supermassive black hole and orbit around it, that is exactly what would happen. That is not science fiction. That is science fact. It's just that we haven't visited any black holes.
Yeah, one of the things I used to do, because I used to tutor maths and science privately, one of the things I used to do is often say, if the sun was replaced by a black hole of equal mass, what would happen? Straight away, everything would get sucked in. Everything would get sucked in. You're like, well, no, equal mass. Nothing would happen apart from the fact there'd be no more light.
Gravity.
Yeah, exactly.
Just don't get too close to it. Right?
Exactly. Yeah. Right. So, Katz and I. So what we do is we use our platforms to try and tell conspiracy theorists that they're wrong, and we try and base it in science. But we rarely see any quantum mechanics-based conspiracy theories, do we? Do you think that's because it is so hard to understand that these people can't think of these conspiracy theories?
It is partly that, but also I think because people don't need to build up conspiracy theories about quantum, because quantum mechanics itself is already weird. I mean, quantum mechanics does lend itself to all sorts of strange ideas, from telepathy to telekinesis or whatever. Anything that people that is supernatural or unexplained by science, the non-science experts, the people who follow some of these wacky ideas, say, oh well, it's quantum. Because and somehow the excuse, because we say quantum mechanics is weird, and a lot of quantum physicists don't like that word because of this issue. Yeah. It's because it's weird. Somehow it gives people license to use it to explain away all sorts of what Brian Cox would call all sorts of woo-woo.
That's good, actually. So if there's anything I don't understand from now on, I can just say, that's quantum.
It's quantum. Yeah, that's right. Yeah.
It's a fair...
Gets you out of all sorts of holes.
Excellent. I'll remember that. There is a growing movement of anti-space conspiracy theorists, believe it or not. So these are people that genuinely believe that space doesn't exist. They think it's a direct violation of the laws of physics. Is that something you've heard of before, these people?
No, I don't think I've heard that. I mean, that's an interesting one. I'd like to sit down and talk to some of these people.
We've got hours of footage if you wanted to know. So, one of the fundamental things that they say, and Katz will know who I'm talking about here, is that they believe that the second law of thermodynamics means that you cannot have an atmosphere next to a vacuum. That's their genuine response to why there couldn't be space.
And do they know that gravity holds the atmosphere in place?
Yeah, but they don't believe in gravity. That's the problem.
They don't believe in gravity?
Yeah, they don't believe in gravity. Yeah.
So are they like the ancient Greeks? They think that we fall back to Earth because we have a tendency to want to get to the center of the Earth. Is that, it's a metaphysical,
possibly? Yeah, they
nonsense.
Yeah, they've got some really weird ideas, but in terms of the space, then this is one of their fundamental arguments that because of the second law of thermodynamics, entropy, that the atmosphere would just go off into the vacuum, because they obviously think that vacuums suck. But I'm not surprised you haven't heard it, because obviously you're not in this world and you don't watch it all the time. But I mean, I do find some of the conspiracy theories, of course, as I'm sure you both do, we find them amusing. They're so silly, they're amusing, and I'll get that I've had letters and emails, as you can imagine, I get on a regular basis. Most of mine tend to revolve around people thinking they've either proven Einstein wrong or they've explained something fundamental in quantum mechanics, like the famous two-slit experiment. Yes.
So they think they're doing good science and they want my seal of approval as a professor of physics. But I don't get the really crazy, the out there sort of, flat Earth, this idea of there being no space. It's funny that they're happy to acknowledge the second law of thermodynamics.
Exactly.
But not to acknowledge gravity.
Yeah, they're happy. Exactly. Yeah.
That's interesting.
They do that. Some of them are very clever at that. They'll use aspects of science to try and disprove other aspects of science which they don't believe in. Right. We always say, you're saying you're happy that this is real, but you're not happy that this is real. Where is your line of belief, of trust in science?
And I always say to conspiracy theorists, what evidence or explanation would it take to persuade you that you're wrong? And they will say nothing. I say, well, okay, well then there's no point us having the debate.
Yeah, exactly. Yeah, Katz and I, when we on episode 1, we had a good chat about the what goes on in the mind of a conspiracy theorist, and we came to the opinion that their minds aren't for changing, and what we worry about is the 10, 20, 30,000 people that watch these people. And that,
absolutely, yes,
and take it in, and
they can't tell the difference between what they're saying and what proper science is saying.
Exactly, yeah. I'm thinking back to when the Large Hadron Collider first opened, and I remember there was actual headlines in the newspapers warning us that the collider could inadvertently create black holes which could go on to swallow up Earth. How much truth was there to that, honestly?
Well, that idea came from the suggestion that there could be such things as mini black holes.
Yes.
So these are tiny, tiny, much smaller than atoms, smaller than subatomic particles that may have been created just from the curvature of space-time just after the Big Bang. And they've been hanging around for billions of years, flying out in space. So, and they evaporate away in what's called Hawking radiation. So maybe we should be able to see them. But the other idea was, well, maybe we can create them. If we have enough energy, if we're creating the conditions of the Big Bang inside Large Hadron Collider, then we should be able to make these mini black holes. They are tiny, tiny subatomic entities, but you can only jam as much energy into them as you've got within the Large Hadron Collider within the collisions. So they're not massive little things that are going to suddenly create an event horizon and suck everything else in them. That would be completely impossible. And a lot of scientists have said, we're not going to be able to create anything of such high energy because we already see those particles naturally occurring in cosmic rays, the particles bombarding us from space. Every now and again, one of them will have much, much higher energy than anything we could have created in the Large Hadron Collider. So if mini black holes were going to appear, we'd have been hit by them in the stream of cosmic rays before now.
Right.
But it was sort of fun.
I mean, so you're telling me the press made something of it that it wasn't?
I found it actually... I mean, a lot of scientists were very sort of infuriated by this, but I found it great because here we were, even tabloid newspapers were talking about a scientific experiment. And, is that the world going to, everyone, guys down the pub were talking about, do you think the world's going to end tomorrow? Do you think we're going to create a black hole? What are these scientists up to? Obviously, it didn't happen, but I think the interest it generated in a scientific experiment in a sense was a good thing, even if people didn't understand the science. And how could they possibly understand the science? It's difficult stuff.
Yeah, completely agree. It was great that it brought it to the forefront of people's minds and this whole experiment. And the Large Hadron Collider. Have you heard any any theories on that one? Conspiracy theories?
I haven't, but
I've heard one. I've heard one, but we'll talk about that later.
Oh, you got. Okay.
I got that one for later.
A question did occur. I just spoke over. There's a bit of a lag there. Sorry, mate. You might have to edit that out. I apologise.
It's fine. Go on.
I've ruined it. We normally do it without an edit.
We normally do a straight shot, don't we? Yeah.
I ruined it. I got a lag on it. I couldn't hear. When you were speaking then, a question did come to my mind, though. And how often is it that the media or the tabloid will misrepresent science to sell papers, misrepresent science of climate change, or misrepresent science of whatever area? How often do you see that, and is it a common occurrence?
It is a common occurrence. I mean, I think by and large, particularly again, this crazy year we've been living through, journalists and science correspondents in the media have by and large been their relationship with scientists has changed, and it's a maturing relationship. And so they're trying to get the stories right. They're not deliberately just trying to misquote or misrepresent science stories just to sell papers. But of course it happens. And I've been involved talking to the media for many, many years. And even though I'm experienced enough to know that a journalist asking me about my research, they're not there to make me look good, to champion my research. Jim has discovered this or that, nor are they there to trash my career. They just want a story. And so I know that, and I know how to give them the story. But even for me, very often they've decided, I've been bitten in the past where they've taken what I've said, twisted it round, and that's basically the opposite of what I said. And then you have to go and try and sort of repair the damage. And I didn't mean that. I didn't say that. I think that happens in all walks of life, and it depends on the integrity of the journalists involved. Yeah, absolutely. But it depends. Like science, possibly could be more harmful if they get that wrong, couldn't it? Than sport or something. And we're seeing that now, for example. Yeah, exactly. So we're realizing that you talk about conspiracy theories. Some of them are fun, and we can pour scorn on them because it doesn't do any harm. If someone doesn't believe we've gone to the moon, or really truly believes the earth is flat, or whatever, or even people who believe, even to some extent, some of the ideas surrounding, say, alternative medicine, the stuff that a lot of scientists feel really need to debunk, it's not as dangerous as spreading ideas about vaccines being dangerous, or the vaccine, because now that's affecting the rest of us as well. And then you do have to sort of somehow fight back and try and find a way of getting the good science over. Yeah. The problem is, Katz and I spend most of our time trying to tell flat earthers that they're wrong. The problem with the flat earthers is it's kind of like a gateway conspiracy. Once you're into flat earth, anything else is good to go. And how so many of them are anti-vaxxers, aren't they, Katz? And so many of them are anti-COVID, it's a COVID hoax and all of this. It's just such a difficult group of people to try and not help, but trying to prove wrong. So we're going to try and use your immense intelligence to ask you, is there a silver bullet for us to tell the flat earthers that they're wrong? Or will they not listen? Well, I mean, I think all the silver bullets that I could think of have been tried and tested with people. You know, the ancient Greeks knew the Earth was round. You know, they measured the circumference of the Earth, statutes to pretty good accuracy.
Yeah.
Scientists in the medieval Islamic Empire, they developed a really clever trick of climbing up a mountain and measuring the angle to the horizon. And from that, they could just use simple trigonometry, and that told them the Earth was round.
Yeah.
And you just look out over the horizon, watch a ship disappear over the horizon. That tells you the Earth is round. So I think these are all supposedly silver bullets, but presumably flat earthers think they have a clever response to all of these.
They do.
They do.
And you know, and they will go to all sorts of tortuous lengths to and because it's, you know, cognitive dissonance sets in, they simply feel too uncomfortable when faced with evidence and data. They will dismiss it, and they're so fixed in their ways. It's if only there were a silver bullet. But I'm not sure whether the answer is to. I guess you both would say to continue debating with them, to continue sort of.
Well, I don't know if that worked. I mean, you mentioned trigonometry. Katz was in a debate once, and he asked a flat earther a trigonometry question, and because it was in miles, he said he doesn't work in miles. It was in kilometers, and he said he only works in miles, so he couldn't do the trigonometry question.
Well, that's just being belligerent and silly, right? I mean, that's. I mean, that person must have known that wasn't a very strong argument.
I think he probably did. Yeah. But it didn't help his case very much. That he couldn't do a trigonometry. I mean, and I said it the other day. It's not necessarily their fault that they can't do these simple maths and know about science.
Yeah, but the dangerous thing is that they very often feel as though they are doing good science. They are being curious and skeptical and following the scientific method. So they think what they're doing is valid and rigorous.
Yeah. Have you seen the documentary on Netflix? On Netflix, the Flat Earth documentary. Have you seen that one yet?
No, I'm aware of it.
Yeah, okay.
I may have to find some time and have a stiff drink.
They do some good science, don't they, Katz? They purchased a gyroscope, a laser gyroscope, and they measured a 15-degree drift, but they didn't accept the results. So they hid the gyroscope in, was it a bismuth chamber? Is that what they put it in?
I think it was.
And they still got a 15-degree drift, but they didn't accept the results. It's just a shame, because some of these people could do some great stuff in science if they didn't believe the Earth was flat. Dear oh dear. Right, okay, let's move on. It's Guess the Conspiracy time. So this is the part of the show where Katz and I both come up with a fake conspiracy theory, and we try and trick the guest into which conspiracy theory is correct. In that, I have to clarify this every time, it's not a real conspiracy theory, and it's what actually happens. It's just something that people believe. Okay. So Katz and I have come up with one each, and there's one that is genuinely true in that people do believe it. It's currently 2-1 to the guests. So we tricked James from Action Lab, didn't we? But the other two have got it right. So me and Katz are looking to try and make it 2-2. So here we go. Number 1. The Large Hadron Collider is a cover for a secret bank vault where NASA stashes all its cash and gold. That's the first conspiracy. Mm-hmm. Number 2. Gravity does not exist, and the mechanism that causes things to fall is relative density. That's number 2. And number 3, the genetic code has a secret 5th base which doesn't ever show up in genetic tests because most doctors don't know how to test for it. Those who have this base are related to the elite, and this is how they are selected at birth and trained to take their place in the shadow organisations that run the planet.
Okay.
So there we go. 2 completely fabricated by Katz and I, and 1 is a genuine conspiracy theory that people believe.
Well, I'd say I'm not that confident of making it 3-1 to the guest, but I would say the middle one, that gravity doesn't exist and that's relative density that causes objects to fall, is the true conspiracy. And the Large Hadron Collider and then the third one about genes, they're made up by you guys.
Is that your final answer?
Yeah.
Yes. Well done. I realised I ballsed that up when I talked about gravity not being real earlier.
Yeah.
I was like, damn it, why did I say that? Because it's going to mess up the game later on. But anyway, it's 3-1 to the guests. Cats, we've got some real making up to do, haven't we?
I was really proud of the one I put forward this week.
Cats came up with the genetic code one. I think we're still being too specific with our conspiracies. We need to be more generalised because it's obvious that we've made them. We're so entrenched in their world. We're just anyway. Jim, it's been a fantastic chat. Thank you so much for coming on. We really appreciate it. Your latest book is The World According to Physics, and that's out now on Amazon, isn't it? And also your novel Sunfall is out as well. So I'm gonna purchase that and I'm gonna read it, and then I'm gonna try and figure out my own book and get that out there. My idea.
Excellent. Thanks for having me on, guys. It's been fun.
It's been a pleasure. Thank you very much. Cats, can you say goodbye, please?
Goodbye. Thank you.
Yeah, thanks, everyone. We'll be back next week when we have Kelly Garardi on. So we'll see you all then. Thank you very much for listening. Goodbye.